Hi everyone. In today's video, we are going to go over a sample RLHF project called Warner Astrologer. Now, this is a coding RLHF project. That means we're trying to improve the model's coding abilities. Now, let us look at the workflow of this project and we'll discuss each and every step that there is. So as soon as you start the task, the first thing that you have to do is to define a goal for the task. What do you want the model to do? What is the aim for the conversation with the model? Now, this goal is not at all an input to the model. It is just for the reviewer to understand what do you want the model to do. And it does not have to be super specific. It can be vague. It could be building a ping pong game or creating a portfolio website. This is a goal. Now, next thing that you have to do is define a prompt itself. Now, the prompt that you're writing has to follow certain constraints. The first constraint being that the prompt has to be very super specific and clear about what it is asking the model to do. For example, in a hypothetical scenario, let's say if I provide a text file to the model and I provide the same text file and I ask the model that, hey, can you analyze this text file? So maybe in one of the responses, the model might analyze how many words are there in this text file, how many action words are there, how many vowels are there in this text file. In another response, however, the model might analyze the factual accuracy of the text that is written inside this text file. So both of these analyses are technically correct. None of them are wrong, but it's just really hard to compare which one of these responses is better than the other one. And you cannot state that because the question itself is very subjective in nature. This is why you should avoid writing subjective prompts and write prompts that clearly specify the objective of the prompt. If you're asking the model to perform a certain type of analysis, you should define that in the prompt itself. Now, there are certain constraints that are defined at the very start of the task itself. Now, the prompt should follow these constraints. The first constraint is a difficulty level. So you are provided with a particular difficulty level. Your prompt should follow that difficulty level. Your prompt should also follow a particular task category, and it should also follow a particular programming language. So these are the three constraints that are defined on the prompt itself. Now there's this other constraint that is defined on the overall task, which is the minimum number of turns that are required before you can submit this task. If you remember our conversation about turns, a minimum number of turns is how many conversations that you have to have with the model before you can complete the task and submit the task. We'll discuss into what this is later on. So here the prompt has to follow a difficulty level, task category, and programming language. Now, let's say you have defined and you've created the perfect prompt, which follows all of these constraints and which meets all of these criteria, in which case you then provide this prompt to the model and the model automatically generates two responses, response A and response B. Now, all you have to do here is to analyze both of these responses and identify if at least one of these responses is a bad response. Because remember, our aim here is to find a failure in the model's response, is to find a deviation here. Now, if at least one of these responses is bad, both of them can be bad as well, but at least one of them should be bad, in which case you have found a deviation in the model's response. Now, what if both of them are correct? If you asked a particular question, both of the responses give you a perfect answer to that particular prompt. This means that your prompt itself is too easy for the model. In that case, you have to rewrite the prompt itself and maybe make it a bit more difficult, add more constraints to it, be more specific about what you want the model to do. In any way, this entirely is an iterative process. You have to make sure that at least one of these responses is bad, in which case you would have to rewrite the prompt a couple of times to identify any gaps in the model's knowledge. Now, let's say you found a gap in the model's knowledge, in which case you have to individually rate each of these responses. You have to individually rate response A. You have to individually rate response B. Now, these ratings happen on 5 categories, which we are going to discuss later on. But just remember that you have to individually rate each of these responses. Now, based on these ratings, you now have to choose a preferred response. A preferred response is basically which one of these responses is better. There could be 3 cases that happen here. First case is, let's say, if response A has a code that is not working and response B has a code that works perfectly. In that case, of course, response B is better than response A, in which case your preferred response would be response B. Now, let's imagine that there's another case where response A has maybe 2 issues with the response response B has 3 issues with the response, in which case response A is actually the better response because it is closer to being the perfect answer. Now, there could be a case where both of them are almost identical and both of them have issues, because remember, when you reach this point, you should at least have issues in one of these model responses. So let's say that both of them have issues. Let's say both of them have approximately 3 issues each. Even in this case, we still need you to choose which one of them is a preferred response. In this case, your choice could be based on very negligible things. For example, one of the model responses could produce more detailed comments in the code, and the other one, just the comments that are there are not that descriptive. You can choose the more detailed comments. Based on even very slightly negligible things, you can choose which one of them gets to be the preferred response. You have to write a justification also on why you chose a particular response to be a preferred response. But once you do, you can choose, if both of the responses are almost identical, you can choose which one of them gets to be the preferred response based on very negligible things. Now, let's say if the preferred response itself contains issues, or a preferred response itself is bad, in which case you need to rewrite the response to make sure that you're fixing any and all of the issues that are there in the preferred response itself. For example, if the preferred response has any issues, in which case you have to rewrite it, which means that you have to become the AI yourself and fix any issues which are there in that particular response. You do not have to provide a feedback as such. You do not have to write that, hey, fix this particular issue. No, you actually have to fix the issues yourself. If, let's say, the code itself in the preferred response is not working, so you have to rewrite that code to make sure that it is working perfectly. If there's any factual inaccuracy in the response, you have to fix that, and you have to tell the model, and you have to give the model the perfect response to this particular prompt. This is called the rewritten response. Now, once you have rewritten a particular response, in that case, your task is basically done. Now, next up, you have to check if you have reached the minimum number of turns. In, let's say, sometimes the minimum number of turns that are defined could be 2, sometimes it could be 3, sometimes it could be 1. In which case, let's say if the minimum number of turns that were defined was 1, so you have completed this particular turn, in which case you have reached the minimum number of turns, in which case you can end the session and submit the task. And let's say if you haven't reached the minimum number of turns, let's say if the minimum number of turns defined was 2, in which case you have to again write a subsequent prompt, which should ask any follow-up questions on the previous prompt. Could be to add new features to the website, to document a particular website. And the subsequent prompt, by the way, does not have to follow any of these constraints that were defined on the original prompt. So the subsequent prompt can be of any difficulty level. It can be of any task category. Programming language should be the same technically, because in most cases, you're going to ask follow-up questions on the pre-existing code itself. But overall, the difficulty level in task categories are constraints that your subsequent prompt does not have to follow. Even in the subsequent turns, you have to you have to get the 2 responses, be iterative about it until you receive a deviation in the model response. Then again, in the subsequent turn, you have to rate individually both of these responses, pick out a preferred response, fix any issues with the preferred response. And in that case, then now you have reached the minimum number of turns, in which case you can end the session and submit the task. If your preferred response is good, however, although this is very rare, in almost 90% of the cases, you have to perform a rewrite on the preferred response. But if it turns out that your preferred response is absolutely perfect with no grammatical errors, no inaccuracies, no code errors, etc., in which case you do not have to rewrite a particular response. You can choose the preferred response itself and then directly finish the task. So this is the workflow of an entire task. Just a quick summary. You have to define a goal, which is not at all super specific. You have to define a prompt which follows certain constraints. After you define a prompt, you have 2 responses from the model, response A and response B. You have to check if at least one of these responses is bad. Both can be bad, but at least one of them should be bad. In which case you have found a deviation in the model's response. Now you have to rate individually how both of these responses performed. Once you have rated these, you have to choose which one of them is the better response. If the preferred response itself is bad, then you have to rewrite that preferred response to make it perfect. In which case, now you can then see if your minimum number of turns is reached. After that, you can end the session and submit the task. In the next video, we will look into the detailed instructions on what are these difficulty levels, what are the task categories, programming language, etc.